In this video on ray optics, we'll be studying about the phenomena of refraction of light. Want to be good in physics? Remember a few things. Physics is like an active sport. To be good in a sport, you must practice. Likewise, to be good in physics, you must practice. The subject demands active participation. You cannot afford to be passive while learning physics. It can be learned by critical thinking alone. And remember, hard work and regularity have no substitute. In the present video, we'll be talking about the phenomena of refraction of light, the laws of refraction, and the principle of reversibility of light. Coming to this refraction of light, the refraction of light is the phenomena of change in path of light as it travels obliquely from one transparent medium to another. As you can see in this diagram, here we have a rarer medium, say air. This rectangle shaded yellow represents a glass slab, and again here we have air. The light ray IO, known as incident ray, was traveling originally in this direction, and as it moves from air to glass, at this point O, it bends towards the normal, comes closer to the normal. This bending of light is what is known as refraction. The rarer medium is the one in which light travels faster, and the denser is one in which the light travels slowly. For example, air is rarer than glass, or glass is denser as compared to air. The light bends towards the normal as it travels from rarer to denser medium. Here it is coming towards the normal, and here at this phase it is entering from glass to air, that is denser to rarer medium. So the light bends slightly away from the normal. There are, however, some exceptions. When light is incident normal to the surface of a slab, or for that matter any interface separating two media, there is no bending or no refraction of light. The refraction is caused by the change in speed of light as it travels from one medium to another medium. The phenomena of refraction of light is governed by two rules or two laws of refraction. The first law is the incident ray, the refracted ray, and the normal to the refracting surface at the point of incidence all lie in the same plane. That is, the incident ray IO, the normal ON, the perpendicular, at the point of incidence, and the refracted ray. All three lie in the same plane. For a given pair of media, and a given color or wavelength of light, the ratio of sine of angle of incidence to the sine of angle of refraction always remains constant. This is also known as Snell's law. Mathematically, we have mu 2 1 equal to sine I over sine r equal to constant. This ratio is called refractive index of medium 2 with respect to medium 1. So far as definition of refractive index is concerned, there are two definitions which we normally use. One is the absolute refractive index of a medium. It is always measured with respect to vacuum or maybe air, because there is not much difference in the two values. The two values very closely agree. So refractive index of a medium denoted by mu is sine of angle in air over sine of angle in the medium. That is speed of light in air or vacuum over speed of light in the medium. And since speed of light in air is denoted by small c and say speed in medium is v, so refractive index will be c by v. Relative refractive index is defined as refractive index of one medium with respect to another. For example, the light may be traveling from glass to water or water to glass. Accordingly, the refractive index may be measured for glass with respect to water or water with respect to glass. Here, if you have two media denoted by medium 2 and medium 1, we have refractive index of 2 with respect to 1 equal to sine of angle in air if medium 1 is air over sine of angle in the medium, that is speed in medium 1 or speed in medium 2 or v1 by v2. Again, about refractive index, you have to remember that refractive index of optically rarer medium is less than that of the denser medium. And refractive index mu of denser medium with respect to rarer medium is always more than 1. Denser with respect to rarer will be more than 1. And rarer with respect to denser will always be less than 1. Because for light traveling from denser to rarer, the light bends away from the normal, and for light traveling from rarer to denser, the light bends towards the normal. In refraction, the velocity and wavelength of light change. This is very important to remember that frequency and phase of light are its fundamental properties. They do not change with change in as light travels from one medium to another. However, the speed of light and the wavelength change. So refractive index of medium m with respect to air is speed of light in air over speed of light in medium, or Ca by Cm can also be written as nu into lambda. Nu is frequency into lambda a over nu lambda m because nu remains same. So refractive index is also wavelength in air divided by wavelength in the medium. Accordingly, you will have refractive index of 2 with respect to 1 equal to reciprocal of refractive index of medium 1 with respect to 2. Now another important principle is the principle of reversibility of light. If we consider this diagram to understand the principle, let's take this diagram. The light originates from this point and travels here through air, and you can see here we have an interface with glass, so the light bends towards the normal. After having undergone this refraction, we make use of a plane mirror to reverse the path of light. That is, this light is incident normal to the surface of the mirror. It is observed that the light retraces its path, that is, it goes to the starting point. So this is how we state the principle of reversibility of light. If the path of a ray of light is reversed after suffering a number of reflections or refractions, it travels back to the source along the same path in opposite direction, undergoing the same number of reflections, refractions, but in opposite order. So we have refractive index of B with respect to A, B with respect to A equal to sin I over sin R, sin I over sin R. Similarly, for reversed ray, the refractive index will be defined for A with respect to B, that will be sine R over sine I. So the product of two refractive indices B with respect to A and A with respect to B is 1, or we get this relation, refractive index of B with respect to A is equal to reciprocal of refractive index of A with respect to B. So remember, another conclusion which we can draw from principle of reversibility of light is the image and the object can be interchanged because the light starting from the object forms the image. On reversal, the image can act as the object and the object can act as the image. That is, the object and the image, they form conjugate pairs. Thanks for watching the video. If you have any feedback or if you want to study about more topics, you may visit the site www.physicsbeacons.com. You may also get notes for various topics in physics. Thank you.
Hey, hey.
Rolla